Yeah, good afternoon, students. In the previous class, we discussed about the instructions and how we can represent the instruction in two different types of notations, like a register notation and assembly language notation. And also, we discussed about the RISC set and CISC set of instructions and how they are differentiated. Now today I would like to discuss about the instruction execution sequence and how the execution sequence can be implemented by making use of this memory that we are going to discuss in today's classroom discussion. So now I would like to share my PPT. So the classroom discussion topic is instruction execution and straight line sequencing. So the today's lecture objectives will develop the knowledge on understanding the process of execution of instruction, how the instruction will be executed, and what are the steps that are there in instruction execution. So we will understand with an example how the straight line execution sequence will be implemented. Now, for example, consider the instruction to perform this addition of two variable values and you want to store that result into a third variable C. So, if this instruction, if you want to perform, so in RISC instruction set, we have already seen that how we can write this RISC instruction set to perform these operations. So, in the RISC instruction set, what are the different types of instructions we have to use? Anyone? Any student, please? What are the instructions? What are the types of instructions we can use in the RISC? Okay, we can use only load and store instruction format we can use here. And the operands are either available in the CPU registers, that is the processor registers, or in the instruction set in the instruction itself. And every instruction always occupies one word in the RISC instruction set. So these points you have to always keep in mind, so that now we are writing that to perform this operation we are writing the code like this in the RISC instruction format. So we are loading the a identifier or a variable value memory operand value into the register CPU register R2 by writing the load R2 comma A. Similarly, the value of B is loaded, okay, into R3. Then after that we will perform the addition. So the addition of R2 and R3, these are acting it as a source operands, and the result will be stored in R4. This is the destination operand. And then after this R4 value is available, the summation of R2 and R3, now we are storing this R4 value into C. Okay, so the processor register value we are loading, we are storing into the, we are writing into the memory operand C. So these are the four instructions we are writing in RISC format to perform this operation. Now how this program is going to be executed, so that is how the instruction execution will be there. Now we will see. To execute this instruction we are assuming that the word length is 32 bits and the memory is byte addressable. Okay, memory is byte addressable and the word length is 32 bit, we are assuming that. So there are four instructions we have seen in the program. Okay, so there are four instructions we have seen in the program. So you see that this is instruction 1, instruction 2, instruction 3 and 4. So these instructions we are loading into the memory. So there are four instructions of the program and they are loaded into the memory, assuming that the first instruction is loaded at the location ith location. So because every word is of 32 bits length, that is nothing but 4 bytes in length. So first instruction is loaded at ith word, because the word length is 4 bytes. The word length is 4 bytes. So every instruction is occupying only one word in the RISC. Please try to understand that. So we have taken the word length as 4 bytes. So every instruction will be stored in one single word only in RISC. Okay, so the first word is loaded at the ith location, and the second word is loaded at I plus 4 location, third word is loaded at I plus 8, and fourth instruction is loaded at I plus 12. So please try to understand these four instructions pertaining to our program segment. To perform this calculation, C is assigned with A plus contents of B. So to do this operation, now we are assuming that the first instruction is loaded at ith location, and because every word is of having 4 bytes in length, 32 bits we have taken, so this is I. Then second word is starts at I plus 4, and the third word will start at I plus 8, and fourth word will at I plus 4 12, and so on. So these are the four instructions which we have written to perform this operation, and this is a four instruction program segment, we can call it as, that is loaded in the memory, in the main memory of the computer. Now these four instructions are loaded in the consecutive locations in the memory words. This is the ith location, I plus 4, I plus 8, I plus 12, and so on. Now this A and B are nothing but the memory words. This is a memory word A. The value of A is loaded here. For example, if you assume 10, the value 10 is loaded here. Like that, this is a memory word, something we have loaded with some value, and the result will be stored here. So the addition of this A and B will be stored here. So this is nothing but what we are calling it as the data for this particular program segment. Okay, the data for this particular program segment. Now how it is performing? So if you see that the execution, how it will be done, the execution of this particular program, if you see that how it will be done, so it will be done like this. The execution will be done like this. First, in order to execute this particular program, the two important registers which are available in the processor, two registers which are available in the processor, already we have discussed these two important registers in the previous classroom discussion topic. Okay, so the two important registers which we are making use in instruction execution is, one is program counter register. Okay, this is called it as PC register, program counter register, and another one is another important register which we are using is IR, instruction register. Okay, these are the two important registers that we have to use when we are executing this particular program segment. Okay, so the processor will contains these two important registers, program counter register. This program counter register will always stores the address of the next instruction to be executed by the processor. So what the PC content, content always hold or stores the address of the next instruction. Okay, so to begin execution of a program, okay, if you want to start the execution of the program by the processor, the PC must be first loaded with the address of the first instruction which has to be executed. So what is this, the address of the first instruction? So the first instruction is starting at address location I. So the PC must be loaded with the PC program counter register must be loaded with the address value I. So that is first. So to begin executing a program, the address of the first instruction in the program must be placed in the program counter register. So once it is placed in the program counter register, now the processor control circuit uses this information available in the PC, and it fetches that instruction from the memory into the processor. Okay, so it will fetches that instruction from the memory into the processor for execution. Now the processor will start executing of that instruction one at a time. Okay, in the order of increasing of the addresses. So this is what we are calling it as a straight line execution. The instructions which are given in the program, the instructions which are given in the program are executed in a straight line. First it will execute ith instruction, later it will execute I plus 4 instruction, later it will execute I plus 8 instruction, and then I plus 12 instruction. So this sequence of instruction execution is called it as a straight line execution. Okay, straight line sequencing we can call it as. So when we are executing here the instruction which is available in the PC program counter. So once we are executing this first instruction, okay, so the instruction execution will always follows two important steps. One is instruction fetch cycle we can call it as, and another important step is that instruction execution cycle. So we have in the instruction execution, these are the two important steps the processor will always follows, that fetch the instruction and then instruction execution cycle. So the fetching is nothing but, so we have to load this next instruction to be executed in the program counter register. So once the program counter is loaded with that next instruction, now the instruction register will be loaded. Okay, the instruction register, that means the what we are calling it as a processor control circuit, will load the instruction which is pointed by the address loaded in the PC into the processor. So once it is available in the processor, now the processor circuit will start the execution of that instruction. So while executing that instruction, so it will be, the instruction will be divided into what is an opcode and what are the operands that are available in the instruction. So it will separate that opcode and the operands. Okay. So based on that opcode, so the instruction, based on that opcode value, the processor will perform the respective operation. So that we will see here in the clear picture. So during the execution of each instruction, the PC is incremented by 4 to point to the next instruction. So first PC is loaded with I, next it is loaded with I plus 4, next it is loaded with I plus 8, like that, and I plus 12 and so on. So that is how it will load that, the sequence of instruction addresses, it will be loaded into the PC. So thus after the store instruction at location I plus 2 is executed, now the PC will contains I plus 16, which is the address of the first instruction of the next program. Okay, so this is how it is going to execute that. So generally the instruction execution will have two phases. So it will follow a two-phase procedure, it will follow. So that two phases are nothing but, in the first phase of instruction execution, which we are calling it as the instruction fetch cycle. Now this instruction fetch cycle, what it does is that the instruction is fetched from the memory location whose address is in the PC program counter. So this instruction, once it is fetched from the memory and it is placed in the instruction register IR in the processor. So once the instruction is placed in the instruction register, now the PC has to be incremented with the next instruction address. Okay, so that is what the instruction fetch. Now the second phase is called it as instruction execution phase. Now during the instruction execution, so whatever the instruction that is available in the IR register, so it will be examined to determine which operation has to be performed, like arithmetic operations or logic operations, what has to be performed by the processor, and where that particular operands are available, so it will be fetching that operand values and perform the operation, either arithmetic or logic operation, and the result will be again stored at the destination location. So that is done in the instruction execution cycle. So at some point of time during this two-phase procedure, so the contents of this PC will be incremented to point to the next instruction. So when the execute phase of the instruction is completed, so the PC contains the address of the next instruction, and this new instruction is fetched again and that is placed in the instruction register. So like this process will be continued until we reach to the end of this program instructions available in the memory. Okay, now it is the point of discussion for you. So one question for refreshing. So how the instructions are executed in the computer. So anyone please here, there are two important steps. Just now we discussed that in instruction execution. So it we follow this two important phases. One is fetch, instruction fetch phase, and another one is instruction execution. So in this, during this particular phase, instruction execution, two important registers are used in the processor. One is program counter register and another one is instruction register. So please try to understand. Okay. So now this is the problem, lecture level practice problem based on this today's classroom discussion topic. So now you try to solve this particular problem. So with a need diagram, explain the execution of this following instruction, how it will be executed. So please draw the diagram, loading of each instruction, assuming that every instruction starting first instruction is loaded at ith memory location, and assume that it is the 32 bits is the memory word length, that is the 4 bytes is the memory word length. Now you can take it as I plus 4 is the second instruction where it is loaded in the main memory. So with the need diagram, try to explain how this particular operation will be performed. Okay. So thank you for patient listening for to this today's session.